Greetings, and welcome to my YouTube channel, Ready to Derive, which I hope will become your go-to source for mathematics help. I've been teaching in the classroom for about 3 decades now, and to this day I never get bored of finding creative ways to explain mathematics to others, regardless of whether they like the subject or not. In fact, one of the greatest testimonies I ever received from a student is as follows: "Even though I don't like mathematics, your class is the one I look forward to the most every day." Whatever your feelings about the subject, I hope my videos will help relieve some of the tedium and perhaps even pique your interest. A little bit about the title of my channel, Ready to Derive. Philosophically, I'm a firm believer that the more a student can appreciate the derivation behind the formulas and algorithms they use, the greater sense of agency they experience and the less they have to rely on rote memorization. So whenever possible, I will lead you through these derivations. I figure now is as good a time as any to show you a brief demo of what I'm talking about. So what follows is an excerpt from a video I made for my students on understanding the point-slope form of a line. See you again at the end of the video. So let's start with this example. Find the equation of the line passing through the point 5,3 with slope 1/2. Now, you may wonder why bother with an equation when we seem to already have enough information to find some other points on this line. So we know that the slope is 1/2, and we know that slope is rise over run. So from the point 5,3, we could kind of move out 2 to the right and 1 up and discover that the coordinates of the point 7, 4, that point is on the line. We could also move to the left and down. So we could move, slope of 1/2 is also equivalent to moving left 4 and down 2, because -2 over -4 would simplify to 1/2. And so we know that the point with coordinates 1, 1 is on this line. So we could generate a lot of points this way, but it's not actually the most efficient. And what if we were curious whether the point with x coordinate 100, what the y coordinate is on this line. So instead, what we're going to do is create a generic point x, y. And this point x, y is allowed to move up and down the line as long as it maintains a slope of 1/2 with the point 5,3. And we're going to go back to first principles, the slope formula. And in the slope formula, we are going to insert our generic point, x, y, and our particular point, 5, 3. So let's do that. So change in y would be y minus 3 over the change in x, which is x minus 5. And we know that the slope of this line has to be 1/2. So that formula always has to be true wherever x and y is located. Now, if we just take x minus 5, which is on the denominator here, and multiply it, that factor, to both sides, we create this equation, which is the equation of a line in point-slope form. And in particular, if we notice that we're really treating 5 as x1 and 3 as y1, what this formula really says is that y minus y1 will equal the slope times x minus x1. And this you should recognize as the general point-slope form. So why is this useful? Well, of course, if I was curious as to when x was 100, what is the y coordinate when x is 100 on this line? It'd be a long way to get out there using a slope of 1/2. But if I just plug in 100 in for x and solve that equation, so 100 minus 5 would be 95 divided by 2 would be 47.5 plus 3 would be 50.5. I have discovered that very easily that the point 100, 50.5 is on this particular line. So now we're going to look at this from an approach using transformations. here we have the 0.53, and we have an equation of this line. This is the line, the green one is the line y equals x. So on that line are the 0.00, 1, 1, 2, 2, etc. It's the basic line without any transformations applied. And now to create the correct slope, that requires the slope to be a half, which is the purple line has a slope of a half. That requires what's called a vertical shrink in this case of 1/2. So the equation of that purple line is y equals 1/2 x. That's where all the y coordinates on the previous line were halved. So whatever the y coordinate was before is now halved to create this purple line. And then the next step is where you notice that the y-intercept of this purple line is 0. And the next step is to do translations in order to get that y-intercept to land on the 0.53. So if you take this y-intercept and move it over 5 units and up 3, you end with the orange line going through the 0.53 with a slope of 1/2. And so that transformation, if we want to shift the line to the right 5, you will recall that that means replacing x with x minus 5. And if we want to shift it, so that's right 5, and we shift it up 3, that would be a plus 3 at the end. So here we see the point slope form again, but in terms of transformations. And that leads to kind of a variation on the formula we saw just before. So this is the classic point slope form, but it can also be written in this form, plus y1 on that side, and both are acceptable. So let's just do one example to conclude. So find the equation of the line passing through the point -6, 1 with slope -3/2. So here's the point slope form formula, and helpful to remind ourselves that these are x1 and y1. And so we just don't replace y, because that's obviously gives us the formula. We need x and y in there as actual variables. So the one place you have to be careful with is that this x minus x1 would be x minus -6. And x minus -6 just simplifies to x plus 6. And so there we have the equation. It's that simple to write in point slope form. It almost feels like you're not doing anything in particular. I might just add 1 to the other side just to give it to you in both forms that we looked at before. And the one thing I want you to be careful with, though, is not to think that this plus 1 hanging out here is the y-intercept. It is not, as I will show you a graph to see pretty clearly. It looks like the y-intercept here is actually -8. So it's definitely not plus 1, which leads us to one last final connection in terms of putting an equation that's in point slope form to slope-intercept form is very easy, and also a great way of finding out the y-intercept if you actually need it. So to do that, to actually convert it into slope-intercept form, all you need to do is actually solve for y, simplify. Well, y is already isolated, so what we really have to do is just distribute -3/2. So we get -3/2 times x, and -3/2 plus times 6 will be -9. And we still have that plus 1 hanging out there. And then that ends up being y equals -3/2 x minus 8. And as you can see, that is not the y-intercept up there, but this indeed is. Hello again. I hope you found that little interlude enlightening. If so, feel free to like the video. In terms of what to expect down the line, I'm hoping to create videos for the full high school mathematics sequence starting with calculus, after which I will take on pre-calculus, algebra 2 trig, geometry, and then algebra 1. After that, who knows? I welcome your suggestions. My hope is to release a couple of videos a week, so stay tuned. So, are you ready to derive? Let's do this.